So I think everybody here is a developer, or most people here are developers, and you probably write asynchronous code. Asynchronous being not synchronous, being multi-threaded. You have to do stuff in the background. And so promises let us do stuff in the background. Oh, I've got my keyboard again. All right. So before we get started, I want to introduce my podcast. I'm starting this up again. I recently interviewed Tong Chao. I think maybe you know him. He's a pretty famous Chinese developer. It's a fun interview, at least for me. nsbrief.com. You can go there and check out some episodes. Also, I was supposed to put up our Lulishuo engineering blog. So if you like engineering blogs on your WeChat, go ahead and scan that. I think maybe we'll put this in the chat room. Scan. WeChat is so handy for the scanning stuff. I think you all can understand my English, right? Am I talking too fast?
No, that's cool.
All right. I usually don't talk so fast, so maybe it's easier for you guys. All right. I think we got everybody scanned. So I want to start in a little bit before we get to promises. The way that we think about promises is not unlike the way that we think about optionals. All right, so we've probably done stuff in Swift, and we have this optional thing, right? So it looks like this if we want to use it, right? So we have some value variable. It could be a var if we want to change it, but we have something in this optional type, which I guess we could also call it like this, optional of t. All it is a generic wrapper around some type. It could be anything, right? But the idea is that we just wrap it. And so the optional syntax could look like this if we didn't have that fancy question mark, just to clarify. And the way we'd use it, the way we want to use it, is to say we have some value and we want to unwrap that value and get the actual value if it's present. If it's not there, then we're not going to do anything. So we're just going to not crash, basically. So when optionals were first introduced as a huge change to the Swift language, or to the Objective-C way of thinking, in Objective-C you could do anything with nil. You could send messages to it and it wouldn't crash. Whereas Swift is the complete opposite, where you have optionals, and if you try to force unwrap an optional, it'll crash. And that's not what people used. So, this kind of turned everything on its head. So the thing about optionals, though, is that when you do the force unwrap and you open the box, it's a bit of a punch in the face in that you don't want it to crash. Right? So you have that syntax to say if let value, safely use it. All right. But the thing with the optional is that if there is no value, there is no information as to why that value is empty. Right? So we have the evolution, the next step onto that is to add an error to say we're computing some value rather than just having a box to hold on to it. So there's a type out there called result, which is basically an OR type. You either have a value or an error. You can never have both of these filled in, right? So you can only have one or the other, and you can just use it like this. Again, it's very similar to the way that the optional works, in that you have optional with some kind of wrapper that's wrapping some kind of type t. I just put any in here just to be more concrete, but it could be a t and then has an error that you know what the error will come out of as. So the way that we can use this result type, like I said, you could either have a value or you can have an error. So you would switch on the result and say, well, the enumeration is going to be either successful, and you can extract the value like this. This is a little bit more syntax to extract the value. And then you can have, if the result is a failure or an error, you just extract the error using a switch statement. So this is the way it kind of works in Swift. This is very standard Swift language, and you would handle it here. And this compiles fine because success and failure are the only two cases. You can't have both. right? So this guarantees that you can only have one value or one error per result. So the thing is, this syntax really kind of sucks. This is really bad to put in your code everywhere. So what you'll probably want to do is use a map function. Right? So if you look on the optional type, there is a map function on optional. So you could say optional.map, and then if the value is there, you can use it. Otherwise, it'll skip over it. You can do the same thing on results. So you have a map function, you transform it, and you transform it to some other result, and you can return the results, a new result with the new error out of there. So you can always have this code a lot cleaner. So what this does is it cleans up your code a little bit. So now you can have result.map and then use the value, and it'll go through that switch statement for you, and you don't have to worry about having all of that switch syntax code all over your code. And you could also have a map error function that will say, well, if there is an error, well, I want to check for the errors instead. And you can do it in a separate block. And you should also be able to chain it, right? So the issue with result, so that's all nice and good, but the issue with result is it's purely synchronous. You have a value or you have an error. There is no idea of asynchronicity of doing things in the background. There is no idea of this in result. And that's where promises come in. So promises are a way to write code in a similar way to optionals and results, but the values come back later. And later is never defined, it's just later, right? It's always in the future. But it gives you some similar semantics. So the way that you would define a promise is very simple. You would just give a type, and you can use it. Now the way that we don't have map in the promise, instead we have the then keyword. So this implies that, well, I promise to have this value. Once the value is there, then do something with the value. So the value is inside of these inside of these curly braces with the actual value that you are requesting, right? So that's kind of nice. And then what you can also do is you can chain an error handler as well. So this is very similar to what we had in that result. The big difference is this is done on a different thread or some other time in the future. It's never done synchronously. So these calls do not block. Whereas if you did this with the result type or an optional type, it would block that current thread. So the way that you would create a promise is you actually give it some kind of completion block. So you initialize it generally, and this is a generalization of syntax. Not all libraries are the same, but this is generally how they'll work. You'll create an instance of an object, and then you'll give it a block, and you'll have two ways you'll have two input blocks in your in the initialization, the actual execution block. You'll have a fulfill and a reject. And what these two things are actually are functions. Fulfill is what you do when you've completed the task, right? So if I've completed the value or I've completed retrieving the value, I'm going to fulfill it by calling this fulfill function with this value. So basically, say if I have some value here, then fulfill it and give it, and the fulfill function has that value here. If I don't have the value, well, I'm going to reject this promise and say, well, there was an error. So reject it. Reject is a function that takes an error as a parameter, so we can create our error here and then just pass it into that function. And now we've completed our promise. Right? So we've ended up, we've completed, we fulfilled the contract that we set out when we created this promise in the first place by returning an object that has promised to fill the value later. This is when you implement later. So you say it's either good or bad with an error or the actual value. And the important thing to note is that all of this stuff in these curly braces here, this is the stuff that happens asynchronously. So these are the things that you'll want to keep track of and handle in the background. The big thing to note is I like to to think about these very similarly. Again, optional, result, and promise. Optional and result have map and flat map. Results might have something called a map error. It may or may not, depending on the implementation that you find. But promises, they change from map and they call it then instead. But it's a very similar idea. And then the on error is also kind of this flat map. And sometimes they call it catch, or there's this dot catch function. So they're very similar ideas with some very similar stuff. So one of the things that you can do with optional or with promises is chain them. So you should be able to just take a promise that you've created and say, well, then do something after that, then do something after that, and just create chains. What you can also do is return this from a function, say you have a function that creates a promise, and then what you want to do is say after that promise has returned, after that promise is there, you can then chain another completion block after that. And then you can distribute when these chains actually occur at various levels up at your hierarchy. So this is kind of nice for saying, in the internals of the framework, I want things to be done a certain way and happen in a certain order. And then when you return it outside of a framework or a particular function call, there's some maybe UI level things that happen after the entire thing under the covers is done. So this is a nice way to distribute all the different ordering that needs to take place. The other thing that you can do with most promise frameworks is group them. So you could do things like you have two promises that have to do something in two different ways asynchronously, two different asynchronous operations. And you can just say when A and B are both done, so this A might take forever, B might not take so long, but when both of them are complete, then we can go do something. So this is useful, for example, if you have two network APIs, one being slow, one being fast, and you just want to wait for the slower one. Or you just want to say it doesn't even matter if they're fast or slow, they're just two different ones. And you need both of them to be able to combine their data somehow. So this will say, okay, now I've downloaded both data sets, so they'll come back in this in the then block at the bottom. So I have a couple of demos. Maybe I can run through these very, very quickly to show you a little bit more how these things work. Alrighty. Alright, so let's go into the Xcodes. So I threw this together at the last minute, but I've got 3 demos here for you, and we can walk through some code. And this is all done with Xcode 9 Beta 2. So hopefully this all works and doesn't crash, but I can't guarantee that. Oh, here we go. Make this bigger somehow. All right. Here we go. All right, so really simple. I've got the first demo is kind of an asynchronous calculation. It's actually going to the network, and hopefully my network is going okay. That looks good. So I downloaded some network data. This is actually going to something called the Star Wars API. I'm just grabbing some data. And so the thing is, right now what it's doing is it's actually, maybe this text is a little too small. Let me make this bigger. All right, is that big enough for everybody to see? You guys can answer, it's okay. I know everybody's quiet and tired, and yeah, but that's all right. I'm not gonna snap at you guys. But so anyway, all I do is when I touch that button, the this fetch data button, it just goes to this perform calculation function here, and all it's doing is going into some network stuff and requesting this URL, and then this is completing. It's using a completion block. So it's just very simple completion block handling code. Right, so this is probably what you're familiar with, and what we want to do is change this into a block, into promises, right? So, so what we actually want to do is, let me see here. So what I've actually got, so this is our function. It uses a URL session and not very well. This is some code that was generated for me, so it's not really that great at networking, but you can see that it uses very simple code to create a data task with its own completion block, and it does its own completion stuff here. So that's all very simple, normal stuff. And we're also using the JSON coding stuff that's in Swift 4. So actually I'm looking for something here because I know I did this before. Oh, yeah, it's there. So that's, I apologize for scrolling so fast. So this is our first function here, the request URL with the completion block. You're totally familiar with that, but I also made an extension down here at the bottom. So this is the request URL, and it returns a promise instead of having a completion block. And the way that we implement the promise is we have our fulfill object here, which is our function. So maybe I can get some, no, can't get any type ahead on this one. Yeah, here we go. So if I do a little bit of help on the type of this fulfill block, you can tell this is a function of type T and it returns nothing. So we're not going to return anything, but we're going to pass in the result, right? And then if I do the same thing with the reject block, it's actually it's a function that takes an error. So I can just call it with any old NS error. And if I want to, I can fill in more data, but I don't have any, or more information, but I don't have any at this particular point. Or actually, I could do this here, else if let error. Oh, it's already done at the top. So there's already something that passes in the error that I have. Otherwise, I don't know what the error is. So I always make sure to reject this promise if it doesn't have the right value. So this is a really simple way to do it, and I'm just wrapping this around the completion block-based API that I've written. And so to use this, I'm going to go ahead and comment out this code. So I've got my request URL. So, and then I'm going to say result label text equals it's going to be, it should be like this. And it might be that I need to say that it is, I need to be more specific with the type, otherwise it won't know what it's doing. All right, so all I did was specify the type, so now all of the generic handling of this request. So this request takes a type T that's encodable. If I don't specify that type anywhere, it can't really figure it out. So just by saying that I want a Star Wars film, which here you can see it's codable, it conforms, it can handle it. So that's fun. All right, and then on error, what I want to do is give it a block here. So self.resultLabel.text equals error.localized description. So that one popped up right away because on error, this $0 here is already typed as an error type. It already knows because that's the way on error is defined. All right, so I should be able to run this again, and let's see what failed. Aha. All right. An extra paren. Alrighty, so if I go back into this demo and fetch data, oh man, demo fail. Maybe not. So what happened on this? Probably pretty obvious to you guys. I have it in the code already. It's calling everything back on the main on the background thread instead of the main thread. So I can only update this label on the main thread, right? Oh, not this. I need to stop it. So basically, I need to say I have it here. All right, and then I can do this here. Aha. Because I can't figure out this one here now. Okay, maybe this will make a little more sense. All right, let's give this another try. All right, so that worked just like before, but instead now it's with promise implementation. So yay, demo. All right, so you don't have to just use promises with networking data or calculations. You can use it with audio. Hopefully this demo will work. I didn't really play the sound, so I don't know, but I've hooked this up to when I press play, it'll play an audio sound, and then it should just show a little message, I think. Okay. Let me undo the breakpoints as I would.
What's wrong? I felt a great disturbance in the force, as if millions of voices suddenly cried out in terror and were suddenly silenced.
Okay. And then there. And there. Hey, it said playback completed. So usually what you have to do with playing audio files in the Cocoa-based frameworks is that you have AV audio player, right? So you have this AV audio player class, right? In order to actually figure out when it's done, so first of all, when you play it, you just call this play function, and you have no idea when it plays. In order to figure out when it does, you have to set a delegate and then implement this audio player did finish playing function. So this is a very old style way of doing asynchronous programming in Cocoa, in that you have an audio, you have basically a finished playing callback method. But if we want to use this with promises, we have to do something a little bit different. So let's go ahead and walk through how this one works. So first of all, when I play a file, all I do is on the main thread, do this, message label text, mark it as playing, and then playback completed and mark the message afterwards, right? So it's the same kind of deal. I have a play promise, so I promise to play this file, and then I want to say the playback completed. Yeah, that's a pretty simple demo. And I've got some helper stuff here to figure out which audio file I want to play, which is just one of these things here. Nothing really fancy there. But what I've done instead is I've created an audio file player object. It has to conform to NS object in order to be a delegate, right? So when I play a file at a URL here, I create an AV audio player and I make itself a delegate. That way down here, it gets that audio player did finish playing callback. And then what we're doing here is that we're still returning the promise. But the secret in this case is that we're holding on to these fulfill and reject functions. There's no reason that you can't fulfill these promises outside of this callback block. It's handy to do everything in that same scope. But if you want to be able to do something that is not typical, I guess, such as converting this callback function, callback delegate function API into something more promise-oriented, all you need to do is hold on to a reference to these functions that are given to you, and then you can call them later. So all it does is, since it has a reference to them, in the extra delegate function, it just calls those functions directly itself. And it has some value for a URL, and we can see here that this fulfill function, it takes a URL and we just give it whatever we had from the player, And the same thing with the reject function. It's just an error. It's just exactly the same signature. And we could go up here and see where it's defined up here. And because we need initializers, we just set default ones. And when we play it, these will kind of do nothing, basically. So rather than having an optional one, we'll always guarantee some function, just have an empty function. So that's a really nice way, I think, to just wrap something as simple as playing an audio file into promises. And now what you could do is you could maybe play a sequence of files. Very simply, just say play this file, then play the next file, then download some audio or download some data. You can start doing things in sequence as long as you can chain your promises. Right? Okay, so the last demo that I have for everybody here, let's see here, is animation. Now this one's not so fancy. It doesn't do a whole lot, just a really simple animation, but it animates and it will mark it as complete. All right. So the way that this one works is, again, I'm sure you could probably guess, is that we have a function here that will animate the ball, right? And all it does is I have a little animator here that will take these animations, and then when they're done, so it'll return, this function here will actually return a promise as to whether the animation has completed, right? So this is basically the same thing as the UI view animation completion block API, where the Boolean flag that's returned is whether the animation is complete or not when that completion block has been called, right? So it's just using the same kind of API, and we can go to the definition here. And all we're doing here is when we call this animation function here, we are using the completion block API from the animation, and we're fulfilling the promise. All right. So again, we do something similar. Actually, we don't do anything similar. We just do it in the same scope as the promise that we have here. So we have a promise object, and then we give it a block that has fulfill and reject. And then in the completion block, which this one is done not asynchronously, it's still all done. All of the stuff is still done on the main thread, but it's done later. Right? So it's done later on in the main thread. And that's why before, remember when I called that network callback, it gave me an error that I couldn't update the UI on the main thread. This one doesn't give me an error on this one because it just uses the thread that it was called from or resolved from. Right? So this completion block is resolved on the main thread. So that means that this call here doesn't need to have the whole dispatch async main or dispatch main async call wrapper around it. It's already on the main thread because it's a UI animation based API. So some simple demos, some simple code, I think. I'll go ahead and post these onto the group. I'll just zip this up into a little demo package you guys can take a look at, see the code. But with that, I think I can take any questions on promises. There's a whole lot more to them that are super useful, but hopefully that's a good introduction. And yeah, if you want to ask any questions. I know some people have questions, right? So quiet. It's okay, guys. You can talk. Yeah.
What is the promise implementation you're using?
This one is called Then. So there are several promise libraries out there. There's Future Kit, there's Promise Kit, there's Then, Bright Futures, and then there's also just one's named Promise, which doesn't really help either.
Why this one?
This one, because I can read the code. There are actually implementing a promise is a little complicated because what it has to do is it has to capture all of those scopes, and it basically keeps a reference to all those blocks. So each implementation has various levels of complexity inside the implementation itself. So to be able to resolve it, it creates a function and gives you the function, and the way that it holds on to those functions is wacky. But this implementation then is very, very easy to understand. And you could debug it if you really needed to. So that's why I use it. It's very simple. Other ones they work just as well, and their API is very similar. Maybe minor changes, but this one is like the easiest framework that I could understand. So I like simplicity a lot, and this one is the simplest for me. But all the other ones work just as well.
Thank you.
Yeah. Any other questions? You guys look a little sleepy. Yeah, go ahead.
Can you compare the RX Swift and Promise Kit? Yeah, I think the in Promise Kit is it's just like the data and software in RX Swift.
Oh yeah. So reactive programming, RX Swift, is a little bit different than promises, right? So reactive programming is maybe a superset of promises, right? So reactive programming is much more stream oriented or signal oriented, right? So you have hot signals, cold signals, and you want to connect to that signal. So when the original value changes on that signal, you can react to that signal. A promise is basically like a signal that you could only fire once, right? So when you fulfill a promise, you can still reference that promise anywhere else, but that value can never change, right? So there are some subtle differences. And also reactive programming has much more APIs. Like in RX Swift, I think there's so many more things that you can do with it. But if all you ever did was say, I have this value or I have this thing that I want and I want it later, and you want to basically cache that value and just reuse it, a promise might be a good candidate for that. I have nothing against reactive programming, but again, leaning on the side of simplicity, which is why I've particularly chosen this particular implementation of promises. I like my code to be simple. So most of the code that I've ever looked at that's reactive is, I could figure it out if I sat there for a long time, and I really don't like to do that. I like to be faster. So it's just, this one's just a little easier, a little more simple to work with. So if you don't need all the extra stuff off of reactive Swift or RX Cocoa or whatever it is, promises are probably good enough. So yeah. Any other questions? All right. Well, if you have questions later, I'll hang around here for a little while. But I guess we'll call it a day, right? I don't know. Where'd he go? Where's our MC?